by 2 raised to n sigma sine j pi by 2 raised to n. J runs from 1 to 2 raised to n as n tends to infinity is equal to. So in order to find this integral, so let us define something called Riemann sum. Riemann sum. So actually we know that if we have a function f of x defined on the interval a to b, okay, so the area under this curve, so area under the curve f of x is given by integral a to b f of x dx. So area is equal to integral a to b f of x dx. Now, what we will do is, so in order to find the area, we have something. So I'm cutting this into n equal intervals. So a naught, I'm calling it x naught, a x x1, x2, etc. xn is. So I'm cutting it into n equal intervals. Okay. So the length of each interval is this. Now, in order to find the area, an approximated area is equal to area of each rectangles. So these rectangles. So area of each rectangle. So I'm approximating this area by using rectangle. Okay. So now, in order to find the first area of first rectangle, this rectangle, so area of first rectangle is equal to, we know that area is length into breadth. So length is actually, so we divided this interval into n equal parts. So length is b minus a by n, because each interval of length b minus a by n. So, and height. So in order to approximate the height, I'm taking this first endpoint. So this is the height. So this height of the rectangle f of x1. So the area of first rectangle is f of x1 into this length. This is b minus a by n. So similarly, we will find area of each. So the total area is equal to f of x1 first rectangle b minus a by n plus, next we will take area of the second rectangle. So I am taking height is f of x2. F of x2 into b minus a by n plus etc. There are n f of xn b minus a by n. Now we know that x1 is equal to actually x0 plus b minus a by n. So which is equal to x0 is a plus b minus a by n. So this is equal to f of a plus b minus a by n into b minus a by n plus x2 is actually x0 plus 2 times. So x2 is equal to actually x1 plus b minus a by n. So this is actually equal to x0 plus 2 into b minus a by n, which is equal to a plus 2 into b minus a by n. So this is f of a plus 2 into b minus a by n into b minus a by n plus etc. plus f of xn is actually a plus n into b minus a by n. That is actually f of b. Okay, so this is equal to sigma. I can write j equal to 1 to n f of a plus j times b minus a by n into b minus a by n. Now, so therefore, if our interval, that means we are cut it into very small ways, that means n tends to infinity, we are summing up all rectangle of smaller length. So this approximation must be exact. So if n is very large area, we know that already integral a to b f of x dx, this is exactly equal to sigma j equal to 1 to, that means limit. Okay, so that is equal to limit where tending n tends to infinity, sigma j equal to 1 to n f of a plus j into b minus a by n into b minus a by n. So this is the formula. So this sum is called Riemann sum. Riemann. Okay. Now, therefore, this integral a to b f of x dx can be written as limit n tends to infinity sigma j equal to 1 to n f of a plus j into b minus a by n into b minus a by n. Now from our question is something okay, so I will delete all this. So I will erase for a better understanding. So our question, we will write a question. We have to find the limit n tends to infinity pi by 2 raised to n into sigma j equal to 1 to 2 raised to n sin j pi by 2 raised to n. So this is equal to limit n tends to infinity. So now we know that as if n tends to infinity, we can write then clearly 2 raised to n tends to infinity. So I am replacing this as limit 2 raised to n. This is actually equal to 2 raised to n infinity pi by 2 raised to n sigma j equal to 1 to 2 raised to n sin j pi by 2 raised to n. Now our formula that we derived is actually there we have cut this into n pieces, that means n pieces. Now here instead of we are cutting x naught and p equal to xn, we are cutting it into 2 raised to n pieces, 2 raised to n pieces. So the formula we have integral a to b that means Riemann sum limit n tends to infinity infinity summation j equal to 1 to n, j equal to 1 to n, f of a plus b minus j times b minus a by n into b minus a by n. So this, if we cut this into 2 raised to n pieces, then this integral can be written as this is actually equal to f of x dx is equal to limit, instead of n we are cut it into 2 raised to n pieces, sigma j equal to 1 to n f of a plus j into b minus a by 2 raised to n into b minus a by 2 raised to n. Now we will what we will do is we will just equate in our equation. So this is our formula. So we will take limit 2 raised to n tends to infinity. Okay, I'm writing like this: summation j equal to 1 to 2 raised to n sine j pi by 2 raised to n into pi by 2 raised to n. Okay, now so from this we will equate. So from here we get f of a plus j times b minus a by 2 raised to n. I'm equating with this sine j times b minus a by b minus a instead of pi by 2 raised to n. So now I can take a equal to 0. So here there is no a times, and b minus a by 2 raised to n is equal to pi by 2 raised to n. So here there is also b minus a by 2 raised to n is pi by 2 raised to n. From here we get a equal to 0, which implies if I put a equal to 0 here and equate, we get b equal to pi. So now our integral this. Okay. Now our integral becomes okay. So our integral is okay. Summation limit 2 raised to n tends to infinity j equal to 1 to 2 raised to n sine j pi by 2 raised to n pi by 2 raised to n. This is equal to integral. You know that formula a is 0 to b by okay, sine instead of a plus we will write x. So sine x dx is pi by 2 raised to n, that is equal to actually that is dx. So dx, so this is equal to minus cos x 0 to pi. If I integrate this minus 1 minus 1, this is equal to